And welcome, and in this video we're going to be talking about graphing quadratic functions using key features, okay? And those key features are going to be any and all intercepts, so any X-intercepts and Y-intercepts, the vertex, and something called the axis of symmetry, okay? And those are the key features that we will be using to graph these quadratic functions. Now, the first thing I like to do when I am graphing quadratic functions using these key features, and the first one I like to find is the Y-intercept. The reason being is because it's actually probably the easiest one to find. So to find the y-intercept of any function, all we have to do is plug in 0 for x and solve for y. And that should make sense because the y-intercept lies on the y-axis, and along the y-axis, x is 0. So what we're going to do is we're going to plug in 0 for x and solve for y. So we go ahead and we plug in 0 for x, so that becomes 0 squared plus 6 times 0 plus 8, and that ends up just getting us 8. Now, what you might have noticed is that the y-intercept ended up just being the constant at the end of the quadratic function, and that's actually always going to be the case if the quadratic equation is written in standard form, ax squared plus bx plus c. So if it's written in that standard form, we can actually quickly find the y-intercept, because if we plug in 0 for x, everything with an x is going to cancel out, leaving us with just the constant. So our y-intercept is the 0.08. Let's go ahead and plot that. So there is our y-intercept. Now the next thing I like to find is actually the vertex. To find the x-coordinate of the vertex, what we do is opposite b over 2a. So for this particular equation, it would be opposite 6, so negative 6 over 2 times a, and a is 1. So to find the x-coordinate vertex, we do opposite b over 2a. So there is the x-coordinate, negative 3. We know that the x-coordinate of the vertex is negative 3. Now, to find the y-coordinate, well, if we think about it, we know the x, so in order to find the y, all we have to do is plug in that x. We have to substitute in that x into the function itself. So to find the y-coordinate when x is negative 3, I'm just going to go ahead and do f of negative 3 to find the y-coordinate. So there we go. We went ahead and we found the y-coordinate by plugging in the x-coordinate. So once you have the x, which remember is opposite b over 2a, finding the y-coordinate is actually pretty straightforward. So we have the vertex of negative 3, negative 1, so let's go ahead and plot that. So there is our vertex plotted. Now there's actually a neat little connection between the vertex and the axis of symmetry. The axis of symmetry is this line that actually slices a parabola perfectly in half, so you can fold it over that line and it matches up perfectly. Parabolas have a lot of symmetry. And what's really nice about the axis of symmetry is that since it actually passes through the vertex, we can actually find the equation of that line very, very quickly. It is always going to be, well, at least for a quadratic function, we're only talking about parabolas opening up and down. We'll talk about parabolas that open horizontally a little bit later once we talk about something called conic sections. But for a parabola that opens vertically, so up or down, it is always going to be the equation x equals, because it's a vertical line, so it's x equals, and it's whatever the x-coordinate of the vertex is, which in this case is negative 3. That would be the equation of this line. Now, I don't normally actually plot the axis of symmetry because it's somewhat unnecessary, but for this example, I will, so you can see the symmetry at the end of the problem. So there is our axis of symmetry plotted. Now what we have to do is we have to find any and all x-intercepts. Now, to find the x-intercepts, we actually set the equation equal to 0 and solve, just like we've been doing this whole time. Remember, whenever you solve a quadratic equation, what you're actually doing is finding the x-intercepts of the graph. Now, just so you know, just like we covered before, you could end up with 2 real solutions, which means there would be 2 x-intercepts. You could end up with only 1 real solution, which means that there would actually only be 1 x-intercept. And it is possible to end up with no real solutions where both of them are imaginary, they're complex conjugates, in which case there will be no x-intercepts. So you can either have 2 x-intercepts, 1 x-intercepts, or no x-intercepts. But to find out, you have to actually go ahead and solve it. So I'm going to set this equation equal to 0 and solve. So there we have it. We have two X-intercepts. Now, if you need help solving quadratic equations, make sure you check out those videos. I'm no longer just going to go through step by step. It is going to be assumed that you guys know how to solve quadratic equations if you're already here. And remember, you could solve by factoring, square root method, completing a square, or quadratic formula. You wouldn't be able to solve by using square roots in this one unless you decided to complete the square, which I found unnecessary. Same thing with the quadratic formula. I found it unnecessary because this factored. And if it factors, that's generally always going to be the most efficient and quickest way to solve. And I got x is equal to -4 and x is equal to -2, which tells me that the x-intercepts are -4 and -2. So I'm going to plot those. And what you should notice is that they both reside exactly one out and one up from the vertex, and that's the axis of symmetry in action. We can actually plot another point if we really wanted to by using the axis of symmetry. If we see this point right here, we had that y-intercept, right? That y-intercept is 3 to the right and 9 up, from the vertex. What that means is that there's actually going to be an equivalent point 3 to the left and 9 up because that axis of symmetry. So I can actually plot that if I wanted to, and I would recommend that you do. You generally want to have like 5 solid points. You want all intercepts, you want the vertex, and then some extra points if you can. And now what you should see is that they kind of mirror one another. And now what we can do is we could connect this using a nice curve. Do not make this a V shape. That is an absolute value. You will be incorrect if you mark it with a V. This is a nice U, okay? It's a parabola. It's a parabolic shape. So we want to connect this with a nice curve. And there is our graph. And as you can see, that axis of symmetry splits it perfectly down the middle. Now, in the future, I actually won't be graphing the axis of symmetry. So let me kind of get rid of it just so you can see it without. But there we go. We have that nice parabolic shape. So that's just one example. Let's go ahead and take a look at another one. So let's go ahead and take a look at another problem. So we have f of x is equal to -3x squared plus 12x minus 9. Now remember, the first thing that I like to find is actually the y-intercept, because all we have to do is plug in 0 for x and solve for y. And since this is written in standard form, I can actually basically just cancel out everything with an x. And all that would be left is -9. So the y-intercept would actually just be the point 0, -9. So I can go ahead and plot that. And feel free to go ahead and actually plug in 0 for x to double check this work, but you would find out that it would just be 0, -9. Now the next thing that I always like to find is the vertex. And remember, the vertex is found, well, the x-coordinate of the vertex is found by doing opposite b over 2a. So that would be -12 over 2 times -3. So let's go ahead and do that. So the x-coordinate of the vertex is going to end up being 2, because once we do opposite b over 2a, that simplifies down to +2. And remember, once you have the x-coordinate, all you have to do to find a y-coordinate is actually plug in the x and simplify or evaluate for y. So let's go ahead and do that. And that would end up getting us the vertex of the point 2, 3. So as we plot that, we should also notice that the axis of symmetry is actually going to be the line x equals 2, because it always passes directly through the vertex. And what that also means is that we can actually plot another point. If you notice, the y-intercept was 2 to the left of the vertex, and what would that be? 12 down. So what we could do is we can actually find another point 2 to the right of the vertex and 12 down. So that would be another point, and that would be very useful to plot. And there is another point, so we should start seeing that symmetry. Now, the last thing that we have to find are the x-intercepts, if there are any, and there might only be one, but now we have to find the x-intercepts. And remember, to do that, we actually plug in 0 for y and we solve for x. So we basically set the equation equal to 0 and we solve. By factoring, square root method, completing the square, or the quadratic formula, your choice. And you need to be able to decipher what method you can and cannot use and what might be the most efficient route. So I'm going to go ahead and solve this equation for x. And there we have it. So we end up getting the x-intercepts of 3 and 1. Now, what I recognize is that everything is divisible by 3, but you never necessarily like to try to factor with a leading coefficient that is not positive. So you never want a negative leading coefficient if you're trying to factor. So instead of dividing by 3, I actually divided by -3. And then I recognize that I could quickly factor that, okay? So that gets me the the X-intercepts of 1, 0, and 3, 0. And now what we should notice is that when we connect this, it's actually going to be a parabola opening down. And the reason it opens down is because the leading coefficient was negative. In the previous problem, the leading coefficient was positive, which is why the parabola opened up. However, when the leading coefficient is negative, it's going to end up being a parabola opening down. So that's kind of another way you can double check your work. Are your points matching up with what direction it should be opening? And here we do see that the vertex is actually the highest point on the graph, which is giving us that notion that it is going to be opening down. So now that we found all of our points, we can connect this with a nice curve. And your curve might be a little bit better than mine, but that gets the job done. So this is graphing quadratic functions using key features. You'll be graphing quadratic inequalities using pretty much the exact same way. The only difference, remember, with inequalities, and we talked about this when we graphed linear inequalities, is it going to be solid or dashed line? Well, in this case, is it going to be a solid or dashed curve? And are you shading above or below? In this case, it's kind of inside or outside the parabola. So make sure you check out that video so you know how to graph those inequalities, and I look forward to seeing you in that video.